Okay. So guys, we'll discuss IPv6 now. So IPv6 and okay. So talking about IPv4, you guys so far you have studied IPv4. So how many bits is IPv4 address? 32 bits, right? So 32 bits, and it is written in 4 octet. Yes, of course it is, and it is written in dotted decimal notation. Okay. So considering IPv6, and again let me tell you, you have already studied about NAT, PAT and all. I already taught you, right? So the PAT will be going with, say we'll translate the private IP to public IP and back. So nowadays, say suppose some years back, IANA has given the last block of public IP for use. Now it is assumed to be, say, reach the exhaustion, or it is like assumed to go deplete. Okay, so now we are going to IPv6. So everyone has started using IPv6. If you check the Geo also started using the IPv6. Okay, so now almost everyone started migrating to IPv6, and let me tell you, IPv6, it's a 128-bit address. It's a 128-bit address. Okay, now it is represented in hexadecimal format. Represented in hexadecimal format. Okay, now, so if I ask you a question, so 128-bit, but it is written in hexadecimal format. So let me ask you, so 1 hexa is equal to how many bits? 1 hexa digit. 6 bits, 16, any other? So I want to represent 1 hexadecimal value. Suppose F. 15 bit. Any other answers? 16 bit. Let me ask you, what made you say 16 bit?
F is 15 and 0 to 15 is 16 bits.
Okay, now I got it. Okay, I didn't ask you how many digits the hexadecimal numbers have, or the hexadecimal number system has. I asked you 1 hexadecimal digit corresponds to how many bits? 1 bit. 2 bit. Now keep on. 3, 4, 5. Now, yes, Sajin. 6 bit. Okay. So
16.
guys, MAC address. So again, 16. Subhash. God. Guys, MAC address is 48-bit address. Now you will represent the 48-bit address using hexadecimal. So how many hexadecimal does the 48 bits has? Means how will you represent the MAC address? So let me just guys, if you can tell me the MAC address, an example. Yes, please. 128. ഒന്ന് പൊട്ടിച്ചേ ബാക്കി ഞാൻ ക്ലാസ്സിന് ശേഷം തരാം. Just a moment guys, let me pause recording. Coming back. Now I don't want to go rebel. Okay, I don't want to be violent. Okay, so I am myself telling the answer. 1 hexadecimal corresponds to 4 bits. 1 hexadecimal value corresponds to 4 bits. Now you guys will tell me, so how this 1 hexadecimal will be 4 bits? Yes, she also has come. Yeah, so she will tell me now. So 1 hexadecimal digit, right? So it's 4 bits. How it became 4 bits? Yes. Anyone? Online guys, Kavya, Selva, Subhash. No one. Okay, so again, now no more close. Okay, guys. Okay, let me tell. Now,
4 bits. 4 bits that values can be added, and it goes up till 15.
yes, suppose at least once 20. Okay. So in the first class, I suppose I have made you write, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. There I have told you to write 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1 like that. We have written up to 15 whose value is 1, 1, 1, 1. And I also told you the value 1, 1, 1 corresponds to, or the hexadecimal value is F. So the hexadecimal value which is from 0 to say 9 and A to F. So again let me tell you, so here each hexadecimal value corresponds to 4 bits, because when it is converted to binary you will have only 4 bits. Confused? Nothing. Okay, let me tell you. So here when I write F, the value F, the hexadecimal, I suppose everyone understood the question, right? Anyone confused with the question? Now, so the value F, the binary value is 1, 1, 1, 1. I suppose this you know it.
Yeah,
Got it. So this is first bit, second bit, third bit and fourth bit. So it corresponds to 4 bit, or 4 bits are called a nibble. It's called a nibble. Okay, so that's what, say here one hexadecimal value corresponds to 4 bits. Okay, now, so got it everyone? Okay, now let me now tell you here what is it. Okay, so we are discussing IPv6 address, and IPv6 address you have 128 bits. Now this 128 bits here we will represent it using hexadecimal, and we will be having 32 hexadecimal digits. Okay, so let me write an IPv6 address, example of an IPv6 address. Regu, got it? Okay, so let me write the example of an IPv6 address like this. Say 0001 A2B3 C4D5 A5B6 C7D7 or D7C7 ABCD 1 2 3 4. So how many values you have? 4, 8, 12, 16, 20, 24, 28 and one more required, right? Okay, so 8111. So this is how you will write 32 hexadecimal numbers. Okay, now after writing the 32 hexadecimal, I'm gonna divide this into say 8 groups. I'm gonna divide it into 8 groups. So 32 divided by 8 will give you 4. So in each group you're gonna have 4 hexadecimal values. Okay, so here you got 4 hexadecimal, another 4, another 4, another 4, another 4, another 4, another 4 and another 4. So how many groups are there? 8 groups are there. 8 into 4, 32. Okay, now to separate each group, what you're gonna do is you're gonna draw, or you're gonna write a, or you're gonna put a say colon in between. Okay, here you will put a colon, here also you will put a colon, another colon, another colon, again next colon, next one, like that. Okay, now we do not have any subnet mask concept here. We'll be writing the prefix length. Okay, so here we'll be writing the prefix length /64. So this is how you will write an IPv6 address. Clear? Okay, so this is the IPv6 example of an IPv6 address.
64.
What is this 64? Yes, let me ask you the same question. What is that 64? Yes, Deva.
Prefixing.
Yes. 192.168.10.4/24. What is this 24?
So
What is this 24, guys?
represent the subnet.
Yes, it's the prefix length. It's called prefix length or the CADR value, or it represents the number of network bits. Okay. Yes. Now let me tell you here. Now some IPv6 address can be shortened. Some IPv6 address can be shortened. Not this one. Okay. This one can be little bit shortened. But let me give you another address. Okay. So the address here is suppose 0001 colon 0002 colon 0003 colon 0008 colon 0012 colon 1234 colon 0000. So how many? 1 2 3 4 5 6 7. Okay, now one more, colon 0001 slash, say suppose 24. I have an IPv6 address like this. Okay, now you can see in this group you can see the preceding zeros, or that means say you got, say at the beginning you got some zeros here. These zeros can be omitted. These zeros can be omitted. So let me tell you, this group can be written like this: 1 colon. This can be written 2. The next one 3. Next one A. Next one 1 2. Next one 1 2 3 4. Again next one 0. Next one 1 slash 24. I can write it like this. Clear? So now it is, again we have shortened it. Okay. Some addresses can be further shortened. Again it can be shortened. Let me tell you. Suppose you are having some IPs like this: 0001 colon 0000 colon 0000 colon 0000 colon 0000 colon 0000 colon 1 2 3 4. So 1 2 3 4 5 6 7, again 7. Okay, so now, so 1 2 3 4 colon ABC. Okay, so now let me tell you, this can be shortened like this. So 1 colon. Okay, now this can be shortened with 0. Now again 0. Again 0. Again 0. Again 0. So how many zeros? 1 2 3 4 5. So again 1 2 3 4 5. Okay, now so 5 zeros, sorry, now 1 2 3 4 colon ABCD. Of course you need to have this slash value also. Without this slash value an IP address is not complete. Okay, so you will write the slash value. Suppose it is having the slash value 60, having the slash value 60. So now, so here slash 60. So here you can see you got continuous 0 group. You got continuous 0 group. So you will write it like this: the continuous 0 group can be written using a double colon. It can be written using a double colon. So 1 double colon 1 2 3 4 colon ABCD slash 60. This is how we will write this IPv6 address. Clear?
So if it is denoted by double colon, how can we know that it is 5 zeros or 4 zeros?
There is any, it's in between that,
In between?
in between the zero, only zeros.
Yes. Let me ask you the same question here. How will they identify whether here you got 5 zeros or 4 zeros or 3 zeros like that?
Maybe 8 hexadecimal values in between.
Got it? Okay. So the answer is here total is 8 groups. You got 8 groups there. Now how many groups are there? Now when we are written, we have got 1, 2 and 3. So the double colon, the computer or the machine will understand 5 zero groups are there. Okay. Now, let me tell you one more thing. So in an IPv6 address, only one time you are able to write the double colon. Only one time you are able to write. Say in an IPv6 address, you will write the double colon only once. You will not use it twice. Getting it? Because of the same reason. If at all it is written twice, then the computer will not be able to check whether how many zero groups will be there in each. Okay. So for that reason, in an IPv6 address, will not be drawing or will not be writing more than one double colon. Clear? Okay. So now, so if I give you an IPv6 address ABCD double colon /64, I suppose now you understand what it is, right? So you have ABCD, and say this double colon means 7 groups are 0. Clear? Okay, that's it. Now, so now going back to theory portion. So here IPv6 address, considering an IPv6 address, they have got 3 transmission methods. They have got 3 transmission methods. What are the transmission methods in IPv4? Simplex, half duplex, full duplex. Half duplex and full duplex. Any more answers? Transmission methods. Okay, then let me ask. What are the transmission modes? Modes are one-to-one, broadcast and multicast. And what is type? Transmission type.
No, modes are simplex, half duplex and full duplex.
Modes are simplex, half duplex, full duplex. Then
Transmission types are
types are
one-to-one, broadcast, multicast.
okay. Then what about transmission methods? Again, guys, wireless. God. Okay. So now let me tell you. So here you got transmission methods. Today that I am not really well to like scold you. Okay. That's why. Okay. You are saved today. Okay. Now, so you got transmission methods which are unicast, multicast, and broadcast. These are transmission methods. Okay. Now, transmission modes are simplex, half duplex, and full duplex. Right. Transmission type, it is broadband, baseband. Right. Similarly, if you check the IPv6 transmission methods, IPv6 transmission methods. It's not mode, it's methods. You have three methods. The first is unicast, the second is multicast, and the third is anycast. You do not have the broadcast here, instead you have anycast. So unicast means one-to-one communication, multicast means one-to-many communication, and anycast means one-to-nearest. I told you we do not have broadcast. Broadcast is what? One-to-all. Now anycast is one-to-nearest. Vaman, what happened to you? So at least Vaman used to become the savior. If at all nobody answers, we'll have Vaman to answer everything. Today he is not even opening his mouth. Okay. Yes. Okay. Yes. Now, so now let me again tell you unicast. Unicast addresses are can be divided into 3. The unicast addresses can be divided into 3. The first is called, you can say, unicast global address. Unicast global address. The second is unique local address. Unique local address. Unique local address. Now the third one is called link local address. Link local address. Okay, let me tell you about these three things. So of course here you can see the unicast global address. So what is global address? Public. Very good. So public address, it is similar, or it is the public IP. Now local address, it refers to the private IP. You got one more thing called link local address, which is local to the particular link. It is local to the particular link. Okay, so now obviously you know, say this public IP and private IP, of course you know it, right, because we have already studied those things. Okay, now link local address, it is automatically created. It's automatically created by the device itself. It's automatically created by the device itself. Okay, now here it's automatically created and it will be of the range FE80:/48, but now let me write 64 range. FE80:/64 range. Okay, so I told you it is automatically calculated by using a method called EUI64. It is automatically created by using a method called UI64. Extended unique identifier. UI means extended unique identifier. Extended unique identifier. Okay, so now let me tell you what it is. So you got UI64 method. Now the address is FE80:/64. So if an address starts with FE80, you need to understand that it is automatically created by the device itself and it is the link local address. It is local to that specific link only. Okay, it's local to the specific link. Now here, let me again tell you here. So I told you the address will be like FE80:/64. If it is /64, then that means 64 bits are reserved for network portion. 64 bits are reserved for network portion. So of course then 64 bits will be reserved for the host portion also, because total you have 128. So if 64 is reserved for network, obviously the 64 will be reserved for host also. Okay, so now again let me tell you here. So FE80/64. Now so the host portion is automatically calculated. The host portion is automatically calculated by using the method UI64. Let me tell you how. They will take the MAC address of the device. They will take the MAC address. Suppose the MAC address is 0001 A2B3 C4D5. Suppose this is the MAC address. If this is the MAC address is a 48-bit address and it is then divided equally. It is then divided equally, or it is split into two equal halves. Okay, Then so the value has become 0001 A2. Then here B3 C4 D5. So here you got 48 bit. You need to make it as 64 bit because you need to have 64 host portion. Okay, so for that what you're going to do is you're going to add 4 hexa values, or you will add 16 bits to make it 64. Getting it? Yes. So here I told you that UI64 method is used to calculate the host portion. How many host portion we have here? 64 bit host portion we have. So we have taken 48 bit MAC address. So how many bits remain? 16 bits remain. Okay, so you have 64 here, 64 bits reserved for host, of which we have taken only the 48 bits, and the rest will be 16 bits. So 64 minus 48, you got 16. So what you did is you have added a 16 bit value, which is FFFE. You added 16 bit value. Now that it has become 64 bits. Okay, now let me tell you now what you're going to do is you're going to invert the 7th bit. Invert the 7th bit. You need to invert the 7th bit. So the 7th bit will be coming in this hexadecimal value. Okay, so here we got 4 bits, another 4 bits. So the 5th bit, 6th bit, 7th and 8th bits will be coming here in this hexadecimal value. Okay, so here the value is this one, 0000, and this 0 will be converted to 1. That 0 will be converted to 1. So what will be the value? 0010. That will be the value. Okay, now when you convert it back,
With this inverted, then it comes in the second hexadecimal value. So second only.
nope, it comes in the second hexadecimal value. What you told is right, but in the second hexadecimal value it comes as a third one, because here you got 4 bits, 4, then this is the 5th one, 6th one and 7th one. Getting it? Okay, now so what you're gonna do is you're gonna invert it to 1, or you're gonna change it to 1. So this value, when you change it to 1, the value will become 2. When you convert it, the value will become 2. So the value will be 0201 A2FF FE B3 C4 D5. This is the value, and the entire address will be or it will become FE80 :0201 A2FF FEB3 C4 D5 /64. This is how the link local address is calculated. Clear?
Yeah, unique for every machine.
Yes.
Can we remove this preceding 0 from the
Of course you can remove it. So the address will be here FE80 :201 A2FF, like that it goes. Okay, and it will be, as Deva has told, it will be a unique value for each machine, and for each machine itself, for each router you have separate different interface, and for each interface you got different MAC address, and so for each interface you have separate link local addresses. Clear? Okay. Rekhu? Okay. Now, so Rekhu, you have cut your hair?
Yes.
Okay. Yes. Now guys, now let me come. So this is the EUI64 method, and this is how they will find the host portion. Okay. Yes. Any doubts? And guys, if at all you're feeling, yeah.
0010.
0010, yes, this value. That answer is? How it comes means that's what I told you. The 7th bit here, the 7th bit is 0. You will convert the 0 to 1. You will convert that to 1. That's, say, that bit is called, I really forgot, UG or some bit. Okay, so that value, the value will be always 0 there. at that value will be converted to 1. Okay, that's a process there, nothing to think about. So that value will be changed to 1. Just mentions that it's the value is changed. That's it. Okay.
Sir,
Yes.
can you use the templates?
Yeah, sure. Just a moment, guys. Increase the temperature. Right. Enough. Okay. Now, so now, shall we, or do you want to write it?
Right.
Okay, right. So now, guys, now that we will go with the next thing. Okay, now we'll study IPv6 subnetting. IPv6 subnetting. Okay. So let me tell you about IPv6 subnetting. We are not going to discuss all the things here, so just gonna show you how it will be done, maybe just an example. Okay, so now suppose that we are going with a VLSM. Okay, so now you are given with an IP 2000:/64. the IP is 2000:/64. Now you have the requirement like this, say 100 machines, 20, 50, 30, 10, 5. These are the requirements. So now let me expand this one. Let me expand it. So 2000:0000 colon, let me expand it completely. Okay, again 0000, now 00, again 0000, again. So yes, you have full complete 0. So how many? 1, 2, 3, 4, 5, 6. Yes, 2 more. 0000000/64. Now let me expand. So this is the these are the hexadecimal values. These are the hexadecimal values. So let me expand these this last group to binary. Let me expand it to binary. Okay, so if I expand it to binary and say let me represent all these 0 groups using double colon. Okay, so here 2000 double colon, and we are gonna expand it to binary here. The last group we are gonna expand it to binary. So when you expand each value, you will have 4 bits, again 4 bits, again 4 bits, again 4 bits. Clear? Okay, so what you're going to do is you're going to expand that into bitwise. So now it will be 0000 colon 0000 colon 0000 colon 0000. Okay, now here we'll be writing the values 1, 2, 4, 8, 16, 32, 64, 128 and all 2 to 6, like that we will write. Okay, now so how many machines you have got here? Say we'll be now writing the requirements in the decreasing order. So the first one will be 100. So 100, 50, 30, 20, 10 and 5. Okay, now so for 100 machines we are going to draw the line between 128 and 64. We are going to draw the line between 128 and 64. So the address will come like this: 2000 double colon, everything is 0 here, everything is 0, so everything can be written in as double colon. Okay, everything together can be written as double colon slash. So now you got in total you got 128 bits. Now how many bits are reserved for network and how many bits are reserved for host? Total you have 128 bits, of which you can see 1, 2, 3, 4, 5, 6, 7. 7 bits are reserved for host, and so 121 bits will be reserved for network. Okay, slash 121. Getting it? Any doubts? Anyone? Okay. Now, next what we are going to do is we are going to write it down. Say 2000 double colon. Okay. Now we'll write it like this: 0000 0000, and now to the left side of the line this is the block size. You know it. To the left side of the line you have block size, but here we will not consider the block size value. Instead what we will do is that we will add this value, or we will say make that value as 1, or we are going to add 1 to the value. Okay, so here you already have, or you are having 0 plus 1 will give you 1 here. So 1, the number will be 1 triple 0, 1 triple 0, then 0 0 0 0. Again, after writing the entire thing, we are going to check for the next requirement, which is 50. So for 50 machines, you are going to draw the line between 64 and 32. You are going to draw the line between 64 and 32. So this time the address will be like this: 2000 double colon, 2000 double colon. Now 00 can be omitted, because in a group you can omit the say first zeros. Okay, now this value is 8. The value is 8. Now so I suppose I have taught you in the very beginning this value 1 triple 0, the value belongs to 8. Now this value is 0. So double colon 80 slash 122. Clear? 8 means it is we have converted this binary to hexadecimal. Okay, so when you convert it, you are going to get the value. Say 0000 will be with the value 0. 0001 will be having a value of 1. Say 0010 will be having a value of 2. Like that it goes, and 0111 will be having the value of 7. 1000 will be having the value of 8. 1001 will be having the value of 9. 1010 will be having the value of 10. 1011 will be having the value of 8. We do not have 11 in hexadecimal, we only have 8. Okay, now sorry, again there is a small thing. We do not even have 10 here. We do not even have 10. In that flow I also told 10. Okay, but again no one to correct, guys. Okay, so I suppose even Vaman gone. Raghu, okay, here those 4. Okay, now so 1010 the value is A. I've told you 0 to 9 and A to F. So up to 9 you can go. Then the next value will be A. Now this value 1 0 1 1 is not A, it is B. Now 1 1 1 0, sorry 1 1, yes, this one is 1 1 0 0. The value is C. Now 1 1 0 1 it is D. 1 1 1 0 it is E, and 1 1 1 1 it is F. Okay. Now don't ask me what is it or how you got it. Okay. Yes. Now let me tell you. So now again you are going to write this value 2000. Okay, double colon. You want to write the next entire thing. So 2000 double colon 0 0 0 0 0 0 0 0. Now 1, and to the left side you will be, what you are going to do is you are going to add 1 here. So the value will be 1 1 0 0. Okay. Now then 0 0 0 0. Now this value will be 2000 double colon. So 1 1 0 0. The value is C. C. Okay. The value is C 0. This value is 0. Okay. So now slash. Now you are going to check for 30 machines. You will be drawing the line between 32 and 16. You added one more bit. You added one more bit. So this time the value will be 123. Then the next thing it will be almost same here. 2000 double colon 0 0 0 0 0 0 0 0. Then to the left side we'll add 1. So this time it will be 1 1 1 0 and 0 0 0 0. So the value is 2000 double colon. These two are skipped because the value is 0, and this value is E. E 0 slash. Now we'll check for 20 machines. For 20 machines we will draw at the same place. We'll draw at the same place. Clear? Okay. So we'll draw at the same place now. So the answer will be slash 123. Okay. Now the next address will be 2000 double colon 0 0 0 0 0 0 0. Now to the left side of the line we are going to add a 1 here. When you add 1, 1 plus 1, what is 1 plus 1? 0 with the carry 1. Okay. So this 0 with the carry 1. Again 1 plus 1 is 0 with the carry 1. Again 1 plus 1 is 0 with the carry 1. So 1 plus 0 here, the value will be 1. Then 0 0 0 0 0. So the value will be 2000 double colon. This value has now become 1. So 1 0 0 slash. For 10 machine you're going to extend one more bit here. Where is it? Getting it? Now the address here now will become slash 124. Okay. Now the next one, 2000 double colon 0 0 0 0 colon 0 0 0 1 and 0 0 0 1. Now 0 0 0 0. Now the address here will become 2000 double colon. So this 0 will be or can be omitted. Now this is 1 and 1 and 0. So it will be 110 slash. Now for 5 machines we are going to again increase one more bit because 5 and 8 will come in here. Okay. So now what happens is that, okay, it will become 125. Clear? Okay. So it is 125. So this is how you're going to do the subnetting. Yes guys, you can note it down. So while you note it down, I'll be back in just a few minutes. Okay. So guys, yes, now I suppose if I give you a question, you will be able to submit. Okay, so maybe later I'll give. Okay, actually thought of giving some question, but now that it's okay. Now let me tell you, now that we'll start implementing the IPv6 in the routers. Okay, we can start implementing IPv6 in the routers and the devices, networking devices. Okay, so here in computers, you know how to give the IPv6 address. IPv4 address, you know how to give it, right? We'll take ncpa.cpl and we are going to get the network connections panel. We'll double click it and there we will, yes. Oh. So now there what we will do is that we'll take this IPv6 and then you're going to give the IPv6 address here with the subnet mask and the default gateway. Okay, this is how you will set the IP address of the computer. Now IPv6 address to the router can be given like this. Let me take the packet tracer again. Let me show it to you. All the configuration is similar to IPv4. All the configuration is similar to IPv4. And again, let me tell you implementation level. So when you implement it, say you might have already implemented IPv4 in the devices, in the computer, in the routers and all. You might have already done the IPv4. In addition to IPv4, you can do the IPv6 also. Together you can do. Together you can do the IPv4 and IPv6. So when you run it both together, then it's called dual stack. It's called dual stack. Okay, so you can do it, but again remember, so these routers need to support IPv6. If at all it's the old router version and all, they may not support IPv6. So the router should support IPv6. Okay, yes, okay. So now, and again let me tell you how they are going to implement. They are really not going to implement it in a single day. They'll be going with portion by portion. Say suppose they may like migrate, so they may be using IPv4 only. Now they'll be like having, or they'll be going with the IPv6 along with the v4. Then if at all they want v4, then if at all they do not want v4, they can remove it also. Okay, now so now let me tell you here, packet tracer, let me tell you how you can do it. So first of all, let me take the router which supports the IPv6. You can see a 2811 series router which will support IPv6. Okay, so let me take two routers here. Okay, now, so now we got two routers. Sorry. Now two routers are there, R1 and R2. Now you can have switches here. You can have the switches, and you can give another switches and some computers as well. Okay, so suppose one is in Bangalore branch and the other is in Delhi branch. So now that you can connect these branches, or these machines can be connected to a switch to the router, then again router to a switch to the say PCs, then we are giving this one, this connection. Suppose that you can, yesterday I might have told you that in the Metro Ethernet you can use the Ethernet standard also, the Ethernet standard. So now if at all you do not want the Ethernet, then you can add the Ethernet interfaces. So if at all you do not have Ethernet, you can turn the device off, then you can take the respective interface here, WIC2T, and then you can drag and drop it. You can just drag and drop. Okay, so here also you can just drag and drop. So let me turn off the device. Now WIC2T, let me just drag and drop it and then turn on the device. Okay, now what we are going to do is we are going to connect the routers, okay, using serial interfaces. So from one serial to another serial we have connected. Now how to do the IPv6 configuration. Let me tell you, it is simple. For computers, we will go to the desktop here, PC, and here you're going to give the IP. Suppose the IP here is in this network, say in this LAN, let the IP address be 1000:/64. 1000:/64. And here suppose it is 2000. So let it be 2000 here. Let it be 2000:/64. And here let it be 3000:/64. Clear? Now here suppose for fast internet 0/0, you can assign the IP address 1000:1/64. And to the machine you are assigning 1000:2/64, and the gateway is 1000:1. And here let me give 1000:3/64. Okay, now the gateway is 1000:1 only. So now let me give it. So here 1000:2/ here you got a slash value. Okay, so it's slash value, it is /64. Now that you will give the gateway address. The gateway address, suppose that I'm giving 1000:1 here. To the router I'm giving 1000:1. The gateway address will be 1000:1 only. Okay, so now let me give 1000:1 here. Similarly, let me give 1000:3/64. 1000:1 will be the gateway. Okay, now here let it be 3000. So here in this case here it is 3000. So let me give 3000 here. (2/64). Now here this one is 3000:1. Okay, now let me give the next IP. (3,3/64). So now 3000:1. So this is how you will assign the IP address to the computer. Now let us assign the IP to the routers. Okay, so now I told you here it is 1000:1/64, and let it be here, let it be 2000:1, and let it be 2000:2, and let this be 3000:1. Shall we do it? So the command is almost similar. We'll go to the interface here. We'll go to the interface, config interface. What's the interface? Fastnet 0/0. Yeah, we'll assign fastnet 0 first. Okay, fastnet 0/0, where we'll give the IP. The command is previously the command was IP address, but now the command is wherever you have IP, you will add IPv6. So the command is IPv6 address, then the address is 1000:1/64. Clear? Yes. Now you have to make this interface up. So the command is no shutdown. And when you check do show IP interface brief, can you see anything? Do show IP interface brief. We have just configured an IP. No, because the table will be separate. They'll be maintaining the table separately. For V4 and V6, they are going to maintain the tables separately. Okay. Okay. I saw something. Right. Okay. So now do show IP V6 interface brief. Here you can see the fastnet 0/0 is up bar upstate, and 1000:1 is the IP address. And you can see an address FE80, which is the link local address, and it is automatically created.
So when it communicates, whether the link local address will be sent or
They'll use the IP for, say, like the routing protocols and all, they'll use the IP. So now let me tell you what is the significance of this link local IP. Okay, Sajin, do you have a girlfriend? No. Okay. Now let me just tell you. Okay, so here, give me a moment. Let me just take the snapshot of this one, or else. Okay. Now, suppose Sajin has a girlfriend. Sajin has a girlfriend. This is Sajin. Okay. And suppose this is, say again, say, where is the paint? Now, suppose this is Sajin. His official name is Sajin. Right. Now, suppose he has got a girlfriend. His girlfriend. Okay. Now, let me tell you. So he will call his girlfriend. Say, suppose his girlfriend's name is, what is your girlfriend's name? Let it be ABC. Let it be ABC. Okay. So Sajin calls ABC. So ABC is her official name. But say during or whenever they talk, they are going to call some other name. Okay. Suppose the girlfriend's name is ABC and he is calling her, suppose PQR. Some name. He's going to call her PQR. Similarly, the girlfriend or whoever it is. So when she is communicating to Sajin, right? So she will be calling some other name. Suppose say XYZ or something. Okay. Now Sajin again in his family. In his family. So again Sajin with his mom and dad, they'll call him with another name. Right? What is the name there? Okay, whatever be the name. Okay, so here you got parents. So the parents, with the parents he'll be having some other name, right? Say suppose maybe like PQR, RST, something.
with friends he'll have another name.
Yes, obviously, definitely. Okay, so again with friends he'll have another name. Not gonna ask that name. Okay. Now, so with each people here, he got another name, and he'll be so careful that so he'll not be telling his name. So whatever his friends is calling, that name he'll not tell to anyone else. Right? Okay. Similarly, so whatever that he is calling his girlfriend or whatever the girlfriend is calling him, he'll not tell that name to anybody else. Right? Okay, same thing. So suppose you got a router. This is the router. Let us replace Sajin with a router. And we got another router here and another router here, and suppose this is a computer. So what happens is that this is a network. This is a network. So within that network or within that link, they can use a link local address. Their scope or the scope of the link local address is limited within that specific link only. Clear? Okay. Now, Susmit. Should I have told Susmit, right? Okay. No worries. Next example will be yours. Okay. Now, so again the same thing. Say if at all you got another router here, another router and another router here. So again, between those two routers, you can have the communication, or they will have the communication with the link local address. Only between those two routers, and that too within that same link. Okay, the same thing. I hope you have understood. So this link local address is non-routable. Okay, now again, so the IPv6 has got many things. Okay, so I told you we do not have the broadcast. We do not have the broadcast. Instead, we only have any cast here. So if at all they do not have the broadcast, you can think about it. How will the ARP work? How will the ARP work? If at all the broadcast is not there, then the ARP is also not there. Instead of the ARP, they are going to use something called NDP, Neighbor Discovery Protocol. Getting it? So some differences are there. Okay, now coming back here, so to our topology. Okay, so this is our topology. Shall we? Okay, so here for fast internet 0/0, we have assigned 1000:1/64. So Sachin, missed something? Sure. Okay, so we have assigned 1000:1/64. So here, where is it? You can see 1000:1 is the fast internet 0/0's IP. Now the next one, which is we are going to assign the serial 0/3/0 IP. So there we'll assign 2000:1/64. So obviously you know it. Okay, we'll go to the interface serial 0/3/0. Then you will give the IP like this: IPv6 address, then 2000:1/64, and we'll give the command no shutdown. Clear? Now the same thing we'll do it in the other router as well. Yes?
So the router has two link local.
Yes, both are different. Let me again show it to you. Do show IPv6 interface brief. So this is the link local address with respect to serial 0/3/0. Now this is the link local address with respect to fast internet 0/0. Both are, even though both are same network, or it's not really considered as the same network. Okay, say both are in different interfaces, so it's considered as different only. Okay, so it starts with FE80 only, but you can see the MAC address you will have. So here, okay, so here actually you will have different MAC addresses. Okay, the interface will be having different MAC addresses. So obviously then this will also get changed. Clear? Okay. Now, so now that we have configured the R1, we'll go to R2. So R2, here you can see, sorry, so here you can see serial 0/3/0 will be configured with IP 2000:2/64. So let me go to the next router and configure. Interface serial 0/3/0, IPv6 address, yes, 2000:2/64, and we'll give no shutdown. Clear? Okay, now the next one, we'll give fast internet 0/1 here. It is FA 0/1 which is connected. So we'll go to fast internet 0/1 and we'll give 3000:1. So we are gonna give to, or we are gonna go to that interface. Say here interface serial fast internet 0/1. Then we'll give the IPv6 address. Then the address is 3000:1/64, and we'll give the command no shut. Clear? Okay. So now that you have already you have configured all the IPs. Now, if you take a look at the routing table, do show IPv6 route. You have two directly connected networks. Okay. So now one has not come up. Let me check why it is. Okay, maybe we didn't give serial. Okay, now you can see. Fast internet 0/1, it is up down. Okay, so let me check why it is up down. Okay, it is not fast internet 0/1, it is fast internet 0/0 only. Okay, it seemed to be fast internet 0/1 when I kept the switch like this. Okay, so it is the switch interface which is fast internet 0/1. We ought to have configured FA 0/0 instead of FA 0/1. Okay. Yes, Ashwin. Okay. So now let me just reconfigure it. I'll go to that interface and let me just give no IPv6 address, and let me give it to interface FA 0/0. Clear? Now that if I yeah, no shut, yes, no shut. Now it is up, and now let me check it. Do show IPv6 root. You can see two routes which are directly connected. One is 2000:/64 and the other is 3000:/64. Similarly, this router, the R1 will also have two routes here. Do show IPv6 route. You can see 1000:/64 is connected to fastnet 0/0, and this one 2000:/64 is connected to serial 0/3/0. Now shall we do the routing? Okay. To do the static routing, the command is simple, straight and simple. So here we are going to go to the config mode, and previously the command was something like this, IP root. Now the command will be IPv6 root. IPv6 root, then we are going to give the unknown network, which is the unknown network here. For R1, the unknown network is 3000. So 3000:/64. Then we are going to give the next hop address, or you can give the exit interface also. Now that suppose we are giving the next hop address. So next hop address here for R1, yes, 2000:2. 2000:2 will be the next hop. Okay, so here 2000:2. Okay, so if you check it, do show IPv6 root, you can see a static root has been created. Now again we need to go to the next router. Again we need to give this. The command is IPv6 root. Then here it is 3000 network, I suppose. Okay, let me check. It's not the 3000 guys. 1000. Okay, here we are given 3000 and here it is 1000. So here 1000. 1000:/64. Then I'm going to give the next hop IP, which is this one. Yes, 2000:1. This one. So let me give 2000:1. Done. So now if you ping from here, say ping 2000, or say suppose it is 3000:2. It's a computer. So if you ping, they should be able to receive it, but they will not get in. You will not get in reply, because let me tell you. Okay, yes, nope, not at all. So let me tell you, by default the IPv6 routing is disabled. By default the IPv6 routing is disabled. You need to enable the routing. So the command here is, we'll go to config mode and we'll mention IPv6 unicast-routing. The command is IPv6 unicast-routing. Okay, so if you enable it, you need to enable it in all the routers here. Okay, so now let me go to the next router, again enable it using the command IPv6 unicast-routing. Now that you have enabled, now let us check whether we are able to ping or not. Yes, now you can see the reply is coming. So now again let me trace route. Trace RT. So you can see it is going via 1000:1, which is R1, then to R2, then to the machine. Clear? Any doubts here?
If you have both IPv4 and IPv6 on the same router, and if you don't enable this unicast routing, then it will be communicating using IPv4.
Yes, IPv4 communication will be there, but V6 will not communicate.
If you enable unicast routing, then it will automatically choose IPv6 or
Both, it will run both. Yes. Okay. Getting it? Okay. Now that this is how you do the static routing. Now shall we do the default routing?
yes.
Okay. So now to do the default routing, so let me first take away the static routing command. Okay. So if you check do show IPv6 root, You cannot see any static routes. You can only see the directly connected routes. Now what you're going to do is we are going to mention the default route. You already know the concepts, right? What is default route and all, you already know it. So now, okay, don't want to ask you questions now. Okay, today not well. Okay, so IPv6 route 0000. Yes, you can say 0000. Yes, guys. Double colon slash 128. Nope. Okay. Let me tell you. Everything has become 0. So you can simply write double colon. That's it. You can simply write double colon slash 0. Got it? It's not 128, it's slash 0. So in say IPv4 also we have did the same. 0.0.0.0.0.0.0. Okay. So double colon slash 0 here. Okay. Then you will give the next hop, which is 2000 double colon 2. 2000 double colon 2. Okay. Now, so here when you check, do show IPv6 route, you can see double colon slash 0 via 2000 double colon slash 2. Clear? So Smith. Okay. Amen. Okay. Not able to focus on you. Okay. Just checking this. Okay, everyone. Now, so this is how. So if at all you ping, again, if at all you ping, you're gonna get the reply. Clear? You know the process, the packet forwarding and all, you already know it. Okay. Now, shall we move to OSPF again? Okay. So now, OSPF. So let me disable all the things here. Say here, let me disable or let me delete the default do show IPv6 route. It's only directly connected network is there. Now, do show IPv6 route. You can see here also you got only directly connected network. Now that we are going with the OSPF, so here you're going to enable the OSPF. So the command is IPv6 router OSPF. The command is IPv6 router OSPF. Yes, 10 or 20, whatever the value you want, you can give. That's the pros ID. So if I give 10, then it's gonna tell an error, or it's gonna show an error, because previously when we have did OSPF in IPv4, I told you it requires read value. If at all you manually didn't give the read value or the router ID value, they're gonna take it. They're gonna check whether any loopback interface has the IP. If at all the loopback interface is configured, they're gonna take that IP as the read value. If at all the loopback interface is not configured, at least the physical interface is configured using IPv4 address. Here we have not created IPv4 address in any router. That's why it is showing the error. OSPF v3 process 10 could not pick a router ID. Please configure manually. So you can now just configure the router ID manually using the command router ID. Suppose it is 1.1.1.1. Clear? Now, then you will exit from there. You will exit. And again, let me tell you what happens. We'll go to the internet. So previously we went into the OSPF, mentioned the directly connected networks. Here we are not gonna do like that. We are gonna participate the interfaces in the OSPF, or you're gonna mention the OSPF in the interfaces. Clear? Okay. Yes. Now, so we'll go to the interfaces. Interface fastnet 0/0. We'll mention the command IPv6 OSPF1 or OSPF10 area 0. Everything is in area. Suppose everything is in area 0. So this is how you're going to give the command. Then we'll go to the next interface. Interface serial 0/1/0. Mention this. Oh, sorry. 0/3/0. I suppose it's 0/3/0. Okay. So let me go to interface serial 0/3/0, where I am going to type the same command IPv6 OSPF10 area 0. Clear? Any doubts? Okay. The same thing will be executed in this router also. Here we'll go to the next router. We'll give the command router IPv6 router. IPv6 router OSPF say 20. Yes, after going into this, we'll give the router ID. Right. So router -id, which is suppose it's 2.2.2.2. Okay, we'll exit from there and then we'll go to the interfaces. Interface fastnet 0/0. We are gonna mention the command IPv6 OSPF 20 area 0. We are gonna go to interface serial 0/3/0. So interface serial 0/3/0. The same command is mentioned. Okay. Clear? And after some time you will see a neighborship will be formed. And adjacency will be formed. Yes, you can see. It has formed the adjacency with neighbor 1.1.1.1, which is R1. Clear? Okay. So now if you check, so IPv6 route, you can see the 1000. So we are in router 2, and router 2 has received the 1000 network with OSPF. Clear? This is how you're going to do the configurations, the basic ones, the very basic ones. Okay. Now the next thing, if at all you want to see the neighbor table, the command is show IPv6 OSPF neighbor. Show IPv6 OSPF neighbor. You can see multiple things here. Okay. You can see multiple interface related things. Now if at all you want to see the neighbor table, the command is do or show IPv6 OSPF neighbor is the command to view the neighbor table. So wherever you have IP, you're going to just change it to IPv6. That's it. Okay. Yes. Now if you check it, so now that again when you check it, the ping will be again successful. Any doubts? Paka? Okay. What about online, guys? Kavya, Selva and Subhash, any questions that you have, or any questions you feel I need to answer? Okay. Okay, guys, then in that case, shall I wind up the class for today?
Okay.
Commands. Okay. So commands, yes. Let me stop recording. So guys, I remember the question that I gave you. The question was like this. Suppose you got R1 and you got R2, and you got switch 1 and switch 2, and you got some computers. Okay. Now, so I told you to say the requirement was something like this. This computer or these computers should be able to take the VTY access of switch 1, router 2 and switch 2. Okay. So are you able to take the VTY access? No. Except switch 2. You are not able to take the connection. Right. Why? Anyone found it out? Guys, whoever tells this answer today, they'll immediately get, I don't have any chocolates. Okay. So before going today, definitely I'll be like giving you a, which one do you want?
First let the answer.
Sorry?
First the answer come.
Then you will have to give me, say 1, 2, 3, 4, 5, 6, 7, 8. I need 8 dairy milk. Okay. No, I don't need dairy milk. You can go with Kit Kat. Okay. Guys, I'm recording.
You are recording.
So guys, if you are able to, have you checked whether you are able to ping the switch 2 or not from this computer?
No.
Not able to ping. Then go with the packet flow. Go with the packet flow. So the packet flow, so here what happens is that when you so both are in different network, obviously it will be forwarded to the router 1, And router 1, it knows the network. You have mentioned the routing also. It will forward to R2. And R2, it knows that this network is directly connected to this interface. Then we'll forward it to the switch. And now let me ask you a question. What will the switch do? The switch needs to reply. So switch will reply back. So the switch is configured with an IP address, that is fine. But if, say, suppose he is in network A and this computer is in network B, if both are in different network, what do you need to configure? Trunk port. I didn't tell you about any VLAN or anything. Routing protocol. God. Any other answers? If at all both are in different network, you need to configure one thing so that it will forward the packet to the concerned device.
Already did routing R2.
Routing doesn't matter at all. What will you configure? So now, let me ask you the same question. Say here, who will tell me? So R1, R2. Okay, let it be faster. Okay, or let it be serial itself. You got switch, you got computers. You got switch, you got computers. R2. Now suppose this is 10.002 and this is 20.002. Okay, so this 10.001 and this is, say, Mac 1 and this is Mac 2. This is 20.001. Sorry, it's not 20, it's 30 suppose. 30.001. This is Mac 3. Sorry, it doesn't have Mac. And this is 30.002. And here suppose like 20.001. This is Mac 3. And this is 20.004 Mac 4. Okay, and this is 20.005 and this is Mac 5. So who can tell me the process that happens when you ping from this 10.002 to 20.005? Who can tell me the process? Who will tell me the process? Ashwin? Yes. Or Susmit? Susmit? Okay, but no. There? Echo? You are losing the Kit Kat chance. Okay. Deva? For the machine, we are pinging from 10.002 computer to 20.005 computer.
ARP will be sent to discover the MAC address.
ARP will be sent. So first, if at all, again, let me tell you. So this is the data. You will pass it through all the layers. Right. So now you got the network layer where they'll add the source IP and the destination IP. The source IP is 10.002 and the destination IP is 20.005. Okay. Now, so here you got the MAC address, the source MAC and the destination MAC. So if at all the destination MAC address is unknown, what they are going to do? They are going to ARP. They are going to send the ARP and get the MAC address of this router's interface. Okay. Now, once they receive it, they are going to say fill that destination MAC address as MAC 1 and will be sent, and the switch will be forwarding it to the router. Router, what he will do is that he will check, say the destination MAC address is MAC 1, he will accept it in layer 2. Then he will send it to layer 3, the network layer, and what he is going to do is he's going to check the packet. Before that, again, let me tell you. Okay, let me tell you before that. So, why, and again, let me ask you, why are they sending the ARP request? Why are they sending the ARP request? Because the destination MAC is unknown. So, which is the destination MAC? What causes the router to think this is the destination MAC? what causes the router to think that this is the destination MAC? Pin drop silence in my classroom. Okay. Guys, simple, very very simple. So this is the destination MAC because both are in different network. Both are in different network. The source IP is in 10 dot network and the destination IP is in 20 dot network. Both are in different network. If both are in different network, it needs to be sent to the gateway. It needs to be sent to the gateway. If it needs to be sent to the gateway's MAC address should be known. Getting it? So that's why to get the MAC address of the gateway, they are sending the ARP. Getting it? I've already told the answer. Already I have told the answer. Okay. Now, anyone got it? Yes, Rekhu. Rekhu won it. But I have told the answer. Okay, that's why Raghu has also told. Let me tell you guys, say, if at all this switch, you are really trying to ping to the switch there. You are really trying to ping to switch 2 here. So the switch 2 might be receiving the ping. But in order to reply back, so when you want to reply back, say then the source IP will be 20.0.0.4, which is the IP address of the switch. And the destination IP will be, which will be the destination IP, 10.0.0.2. So both are in different network. If both are in different network, what do you need to configure? You need to configure default gateway. So guys, here the same thing. Whenever this computer wants to communicate to another network, only if the default gateway is configured, they will be sending the packets or they will be sending the frames to the gateway. Same thing. Getting it?
Yes.
Yes or no?
Yes.
Anyone who still has confusion? Okay. Yes, Rekhu. So, at least Rekhu. Now, Vaman is out of the picture. Okay. Now, so what happens is that, say you need to set the, or the solution is that you need to set the gateway to the switch. So the gateway will be this router's interface IP. So the gateway address can be set like this. You can go to the switch and you can go to the config mode. The command is, I suppose, default IP default hyphen gateway. It ought to be IP default hyphen gateway. Then you're gonna give the gateway address to switch. Clear? Okay. So now let me stop recording.